Hello dear students, let's discuss the most important MCQ from the chapter Solutions. Right. Let's start from 2024 board exam, what they were asked. A simple question they were asked from previous board question. Isotonic solutions have the same. Directly we can answer, right? What are isotonic solutions? The solutions having same osmotic pressure, right? Those solutions having same osmotic pressure, what we call isotonic. The one with a higher osmotic pressure, what we call hypertonic. The one with a low osmotic pressure, we call hypotonic. Question number 2. Which of the following unit is useful in relating the concentration of solution with its vapor pressure? Which one? Mole fraction. We studied Henry's law. What is Henry's law? Says that partial pressure, the vapor pressure of the gas is directly proportional to what? Its mole fraction. So, mole fraction is the term we are using to express the concentration with these kind of laws, right? And similarly, Raoult's law, the vapor pressure, the partial pressure is directly proportional to its mole fraction. That's it. So, vapor pressure, the partial pressure is relating with which term? Mole fraction. That is the concentration terms we are using. On dissolving sugar in water, they are going to dissolve sugar in water. Sugar is the solute, water is the solvent. At room temperature, okay, under which of the following case the dissolution, which means solubility of sugar, will be the most rapid? See all, if you have a sugar salt, a crystal, and sugar powder, which is easy to dissolve, sugar powder, right? Because when a big crystal, it will take long time to dissolve. So why? When you make this big crystal into small pieces, what happened in small powder? What happened? Surface area increase, so solubility increase. Okay, so first thing, powdered sugar is there, which means more solubility. Second one, whether cold condition or hot condition, we can dissolve more amount. Of course, hot condition, right? If you heat the solution, what happens? Solubility can be increased. So, powdered sugar and hot water is the best to dissolve more amount of sugar in water. Maximum amount of a solid solute that can be dissolved in a specified amount of a given liquid solvent does not depend upon. See, solid solute dissolved in a specified amount of liquid solvent, solid in liquid, does not depend on, what we can say, pressure. Because pressure, there is no effect on solid, right? Pressure effect only in which one? Gas in liquid system. Solid in liquid, if you apply pressure, no effect. Next, low concentration of oxygen in the blood and tissues of people living at a high altitude. We studied mountain climbers, or those people are staying at a high altitude. Pressure is very less. Because of less pressure, less oxygen can intake, right? So what is the reason? Low concentration of oxygen in the blood at a high altitude is because of what? Low atmospheric pressure, according to Henry's law. Next one. Considering the formation, breaking and strength of hydrogen bond, predict which of the following mixture will show positive deviation. We studied many examples for positive and negative deviation, which will show positive deviation. Can you say, my dear, which all example we studied under positive deviation? Methanol and acetone. Generally, alcohol with acetone, we studied in positive deviation. Chloroform and acetone is negative deviation. Acid and water is negative deviation. Phenol and aniline, negative deviation. Colligative property depend upon number of solute particle, not on the nature of the particle. It depends on the number of solute particle in the solution, number of solute. Which of the following aqueous solution should have the highest boiling point? Remember all of you, higher the number of particle, higher boiling point. So, higher boiling point means higher particles, higher number of particles. Can you say who can give more number of particles? See, the molarity is same. So, just to check, NaOH can give you Na plus and OH minus. How many ions? 2 ions. Na2SO4 can give you 2 Na plus and SO4 2 minus, right? Total 2 plus 1, 3 ions. NH4NO3 will give you NH4 plus and NO3 minus, total 2 ions. And KNO3 will give you K plus and NO3 minus, that's also 2 ion. So which is giving more number of ion? Option B, more number of ions if it given mean more boiling point and less freezing point. Next, in comparison to 0.01 molar solution of glucose, the depression in freezing point of 0.01 molar MgCl2 solution is very simple. See, actually molality is the one concentration, that's just a concentration. What is the depression in freezing point they're asking? What is depression in freezing point expression? Delta TF is equal to I into Kf into M, right? Molality. So delta TF is the factor they're asking. What is the first solution? 0.01 molar means concentration solution of glucose. Okay, glucose solution. Glucose solution. What is the other one? Same concentration, 0.01 molar MgCl2 solution. See, solution in the sense what? Water is the solvent, right? Glucose solution mean glucose in water. MgCl2 solution mean MgCl2 in water. So water is the solvent. Water Kf value is constant. So Kf, what is Kf? Cryoscopic constant. It is a constant for a particular solvent. So Kf is independent. Even molality also, that is independent. Both concentrations same. So only delta TF depend on what? I. So what is the delta TF of this one? See, glucose, we studied glucose is a non-electrolyte. They do not split. So that I value is 1. Whereas here delta TF is equal to, what is the MgCl2 Van Hoff factor? MgCl2 give you Mg2 plus and 2Cl, total 3 ions. So tell me, compared to glucose, this MgCl2 depression in freezing point is 3 times because it's depend only on I value. So about 3 times Van Hoff factor, right? Therefore delta TF is 3 times increased. Next one, an unripe mango placed in a concentrated salt solution to prepare pickle shrivel because, you know, a unripened mango, a raw mango, when you kept in salt solution, it will shrink, right? That is due to osmosis. That is because of what? It loses water due to not reverse osmosis. It gains water, right, all of you? It loses water due to osmosis. From raw mango, the mango pulp or the liquid part is leaching, that is coming out to the salt solution because salt solution is hypertonic, high osmotic pressure. We already studied when you keep a substance in hypertonic solution, what happens? That gets shrink, right? So an unripe mango placed in a concentrated solution to make pickle, that shrivel because of what? That loses water due to osmosis. At a given temperature, osmotic pressure of a concentrated solution of a substance. What is expression for osmotic pressure? Pi equal to I into CRT. Means pi is directly proportional to Van Hoff factor, concentration, R is a constant, and temperature. So how at a given temperature, osmotic pressure of a concentrated solution of a substance, what we can say is higher than that of dilute solution, lower than that of dilute solution. What we can say? Higher than, because concentrated solution. More the concentration, what we can say? More osmotic pressure. So at a given temperature, osmotic pressure of a concentrated solution, as concentration increases, osmotic pressure will be higher than the dilute. Which of the following statement is false? 1. 2 different solutions of sucrose of same molality, okay? 2 different solution of sucrose. So here sucrose solution, here also sucrose solution. 2 different solutions of sucrose of same molality, okay? Molality same, prepared in different solvent, okay? So solvent 1 and solvent 2 will have the same depression in freezing point. No, that is our answer. Why? See all, delta TF is equal to I into Kf into M, right? Here M remain constant, okay. Sucrose I value, that is also constant, okay. But Kf value is what? Kf is a constant for a particular solvent. Here is a solvent 1, this is solvent 2. Different solvents having different Kf value, so their delta Tf will be different. They said it is same. Option A. What about B? Osmotic pressure is given by pi equal to CRT, correct. And decreasing order of osmotic pressure for 0.01 molar aqueous solution of barium chloride, potassium chloride, acetic acid, correct all. See, barium chloride give more ions, so more osmotic pressure. Then KCl, then weak acid, okay, weak acid, CH3COH, sucrose, non-electrolyte. According to Raoult's law, vapor pressure exerted by volatile component of a solution is directly proportional to S mole fraction, correct, option A. The value of Van Hoff factor for KCl, dear all, KCl give you how many ions? K plus and Cl minus, so Van Hoff factor 2. And NaCl give you what? How many ions? Na plus and Cl minus 2 ions 2. And K2SO4 will give you what? 2K plus and SO4 2 minus, total 2 plus 1, 3. So 2, 2, 3. That will give you 2, 2, 3. Just dissociation means what? How many particles are getting after dissociation? Just check. Next, value of Henry's constant. Remember all, Henry's constant inversely proportional to which one? Solubility of the gas, but KH value directly proportional to which one? Temperature. Okay, so value of Henry's constant KH increases with increase in temperature. Yes, depend on temperature, they are directly proportional. But the value of Henry's constant KH is, what we can say here, solubility they are asking. So we can say greater for gases with a lower solubility, because as KH value increases, solubility decreases. We have 3 aqueous solution of NaCl labeled as ABC. Okay, ABC. There are 3 solution which all of them contain as a solute NaCl, NaCl, NaCl. And the concentration is given 0.1, 0.01, 0.001 molar. Value of Van Hoff factor for the solution. Dear all, Van Hoff factor not depend on concentration. Van Hoff factor mainly depends on solute. See, NaCl will break down as what? Na plus and Cl minus in all this case. So, I value remain the same in all solution. Why so? Van Hoff factor is independent of what? Actually concentration. If they change concentration, okay, solute is remain same, right? What is the solute? NaCl. NaCl I value is what? 2. That's it. If 2 liquids A and B form minimum boiling azeotrope at same composition. We studied that. Who will form minimum boiling azeotrope? They're all positive deviation, right? Who will form positive, right? Positive deviation forms which one? Minimum boiling azeotrope. In positive deviation, what is the reason we studied? AB interaction is weaker than AA and BB interaction. That is the reason. Because AB interaction is weaker, it forms minimum boiling azeotrope. Where is that answer? AB interaction are stronger? No. Then where we can say all of you, option D, right? AB interactions are weaker than AA and BB. Yes. So all of you, there are 2 azeotrope, maximum boiling and minimum boiling. Minimum boiling azeotropes are formed by which one? Positive deviation, because in positive deviation, AB interaction is weaker than AA and BB. Next one. KH, Henry's constant for different values are given. Argon, carbon dioxide, methanol and methane are given. Okay, notice the value all of you. 10 raised to 5, okay, 0.413. This is 10 raised to 5, okay, my dear, 10 raised to 5, you consider. Arrange these gases in the order of their increasing solubility. Higher the KH value, what? Lower the solubility. So, which one having higher the KH value? I think this is the 10 raised to minus 5. Let me check, just to check it, okay, minus 5 if it is so. Which one having greatest value here? This argon having greatest value. This is minus 5, okay, 10 raised to minus 5 you consider. So, argon having greatest value, greatest KH mean least solubility. So, which one having least solubility? Where is argon? Okay, argon is here. After argon, we can go to 1.67. Which one? Carbon dioxide, then which one, this 0.413 methane, and then we have HCHO, because this is 10 raised to minus 5, okay my dear. So option C, let's go with, okay. So higher the KH value, very least solubility. And this is the very least value for methanol, and it's having very highest solubility, right. In comparison to another question. In comparison to 0.01 molar solution of glucose, the depression in freezing point of 0.01 molar MgSO4 is same one question we discussed. Those solution, they are in same solution. They said just a solution. That means solvent is water. If solvent is water, its Kf value is constant, so Kf would not affect. Concentration also similar, so only I value detect. So what is the I value of glucose? 1, because it's a non-electrolyte. But MgSO4, you know, that will break down as what? Mg2 plus and SO4 2 minus. So I value is equal to what? 2. So here it is 1 time, here is 2 times. So the depression in freezing point increased by 2 times. About twice. 20. Which of the following aqueous solution have higher boiling point? Already we discussed. Greater the number of particle, greater the boiling point. Which one having greatest boiling point, all of you? See, glucose do not split, right? It exists as 1. Na2SO4 exists as 2 Na plus and SO4 2 minus. Total how many ions? 3 ions. KCl will give you K plus and Cl minus 2 ion. Urea is a non-electrolyte, it do not dissociate. So which will giving more ions? Option B, more number of ions mean high boiling point. Which is not a colligative property. Not a colligative property. Come on, quick. Which one? Osmotic pressure, yes. Lowering of vapor pressure, yes. Depression in freezing point, yes. Molar elevation constant. Molar elevation constant is Kb, right? It's a constant, not a colligative property. The solution that form maximum boiling azeotrope. Maximum boiling azeotropes are formed by negative deviation. Which is a negative deviation? Negative deviation. Can you identify? Chloroform and acetone is negative deviation, right? Which of the following is dependent on temperature? Depend on temperature. Which one mainly? Molarity. Because you know molarity is depend. Molarity, what is the expression? WB by MB into 1000 divided by volume. See, volume term is there in molarity. So when temperature changes, volume changes, molarity changes. So molarity is the one dependent on temperature. Osmotic pressure of a solution is, see, osmotic pressure is given 0.0821 atm at a temperature of 300 Kelvin. The concentration in moles per liter will be, means concentration we need to calculate. Osmotic pressure of a solution, they didn't say anything about the solute, so I value we can take it as 1. So our equation pi equal to what? CRT. Pi is 0.0821. C is supposed to calculate what is universal gas constant 0.0821 into what? Temperature is 300. See all of you, this one we can cancel. So C equal to 1 by which one? 300. That's equal to what? 0.0033 we can get it. Ready all? So like that, such a way we can able to calculate the terms. And the atmospheric pollution is generally measured in which unit? Atmospheric pollution, see there, which all are the polluted gas in very minute quantity it will be there, the pollutions and all. For a particular gas or a pollution when you consider, it will be very minute quantity. So minute quantity, if the concentration is very less in number, the method which you are using to calculate the concentration is which one? Parts per million. Here is the 26th question. Partial pressure of a solution component is directly proportional to its mole fraction. This is known as which law? Whether it is Henry's law or Raoult's law. Partial pressure of a solution component, solution. Which is, what is the law is called? Raoult's law, right? Partial pressure of any volatile component in a solution is directly proportional to what? Its mole fraction in the solution is given by Raoult's law. the system that form maximum boiling azeotrope. Again, maximum boiling azeotropes formed by what? Negative deviation. Who will give negative deviation? Again, acetone and chloroform. See, ethanol and acetone we studied in positive deviation. N-hexane and N-heptane is which one? The ideal solution and all. Right. Carbon disulfide acetone we discussed in this case. Which one? The positive deviation. So, acetone and chloroform negative deviation form maximum boiling azeotrope. A plant cell shrink when it is kept in hypertonic solution. In hypertonic solution, particle gets shrink. In hypotonic, it gets swell. The relative lowering in vapor pressure is proportional to the ratio of number of what? We know relative lowering of vapor pressure is given by P naught A minus PA by P naught A is equal to what? Chi B. Yes or no? This is our relative lowering of vapor pressure, that is equal to chi B. What is chi B? Number of moles of B divided by total number of moles. So where is that expression? It is the solute molecule. What is this solute, right? Solute molecules to the total number of molecules in solution, option C. So relative lowering of vapor pressure directly proportional to number of solute particle to the total number of solution particle, no, number of moles. Then the osmotic pressure of a solution can be increased by, osmotic pressure equal to CRT or ICRT. R is a constant. Mainly osmotic pressure depend on what? Concentration. So if you increase the concentration or the number of particle, osmotic pressure can be increased. So increasing the number of solute particle. As we increase the number of solute particle, concentration increases, osmotic pressure increases. Next, sprinkling of salt helps in clearing the snow-covered roads in hill. In the snow region, what they are doing, they will pour this salt. They can lower the freezing point of which one? The snow. Lowering in vapor pressure, no. Depression in freezing point of snow, yes. The salt is a solute, right? Solute, when you add to the solvent, what happened? The freezing point, what happened? That decreases. So the more the particle comes, more solute particles come, especially here salt is a solute. When you pour on the surface of the snow, what happened? That will reduce that depression in freezing point of snow. For carrying reverse osmosis for desalination of water, we studied desalination of seawater is a application of reverse osmosis. The semi-permeable membrane is made up of, we discussed cellulose acetate, right? Semi-permeable membrane is made up of which one? Cellulose acetate. What will be the degree of dissociation? What is the expression for degree of dissociation? Alpha is equal to I minus 1 by N minus 1. Of 0.1 molar, molarity is not a factor. MgNO3 twice solution if Van Hoff factor. See, Van Hoff factor already given 2.74 minus 1 by, what is the N value? N value, how to calculate? How many ions are giving by the species? MgNO3 give you Mg2 plus and 2NO3 minus, total 1 plus 2, 3 ion. So 3 minus 1. So 1.74 divided by 2, that is the value, and the final answer we will calculate in what? Percentage. So that you divided by 2 and how much you will get? Around 17 by 2 if you calculate it. 8 something comes. Yes, 87% comes. So what is the equation to calculate alpha, my dear? I minus 1 by N minus 1. I is the Van Hoff factor already given 2.74 minus 1 by, how to calculate N? If it is dissociation, check how many particles you are getting after dissociation. MgNO3 twice on dissociation, you will get 3 ions. So 3 minus 1 overall. And final answer, you should multiply with 100 because alpha is expressed in percentage. If molality of the dilute solution is double, the value of molar depression constant, delta TF is equal to I into KF into M. They are going to change the molality double. Even if you change molality, double, triple, whatever, see dear all, Kf may change? No. Kf is what? It's a molar depression constant. It is a constant for a particular solvent. It does not varies with which one the concentration. So unchanged. Isotonic solution have what? Isotonic solution have same osmotic pressure. That's already we discussed. It's a 2024 board question. The Van Hoff factor I for a dilute aqueous solution of the strong electrolyte barium hydroxide. What is barium hydroxide? BaOH twice. Barium hydroxide, what is the I values? You know this will split it as Ba2 plus and 2OH minus, total 1 plus 2, 3 ions can produce, right? Barium hydroxide can give you 3 ions. When, what is the mass percentage? What is the equation to calculate mass percentage? Have you remember? Mass percentage is calculated by mass of that component divided by total mass into 100. See, 22 gram benzene is there dissolved in 122 gram carbon tetrachloride. Ready? So what is the mass percentage of carbon tetrachloride? So what is the weight of carbon tetrachloride? 122. What is the total weight of the solution? 22 plus 122. So 122 divided by 144 into 100. All of you just calculate it. It's a biggest in number, right? So that will be around 84.72%. You will get it. Just to cross check it, all of you. So what is the equation to calculate mass percentage? Mass of that component divided by total mass of the compound into 100. What is the molarity? What is the expression for molarity? WB by MB into 1000 divided by what? Volume. Ready all? Ready all? Let us calculate. 10 gram of NaOH in 500 ml. So what is 10 gram? Weight of solute. That is WB, 10 gram. What is the molar mass of NaOH? Remember, sodium mass is 23, oxygen mass is 16, hydrogen 1. How much you will get it? 40 gram per mole. So 10 by 40 into 1000 divided by what is the volume given? 500 ml. How much it is, all of you? Calculate it. It is 2, right? So 2 divided by 4, that is equal to 1 by 2. 1 by 2 is equal to what? 0.5 mole per liter. So molarity is calculated by what? Given mass by molar mass into 1000 divided by volume can be applied. Next question, 3 moles of P, okay? 3 moles of P combining with 2 moles of Q are mixed. Then there will be a total vapor pressure in the solution of their partial pressure. See, their individual partial pressure is given, that is P, let me take it this P component as A component and the Q component as B component. So P naught A, its pressure is given, how much it is? 80 torr, and its pressure is given 60 torr, right? 60 torr. Question is to calculate what is the total pressure. We have an equation under Raoult's law we derive. Total, P total is equal to P naught A plus chi B into P naught B minus P naught A. Let us substitute. Then whose thing we need to calculate? They just said, let me take it as this is A, this is B component. Okay. So A component is 80. Its pressure is 80 plus, what is chi B? How to calculate chi B? Chi B is calculated by number of moles of B by total number of moles. So B component is this one, right? So its number of moles is 2 and total number of moles 2 plus 3, 5. So 2 by 5. So 2 by 5 into, what is P naught B? 60 minus, what is this? 80, right? So can you simplify all of you? You will get 80 plus, what is 2 by 5 into minus 2 by 5 into minus 20. Yes, we will getting 4 time, right? 4 into 2, 8. So 80 minus 80 equal to how much all? 72 torr. We get it, 72 torr. So remember this equation all. This is the equation we studied to calculate the total pressure of which one? The solution. 2 liquids, nitric acid and water. First thing, you know, nitric acid and water. Acid, when you mix with the water, we already studied this percentage and all. 68% nitric acid, 32% water and all. Water when combined with the acid, that will form negative deviation. Okay, negative deviation. So first and the negative. They already given. Negative deviation, they form what? Maximum boiling azeotrope. You know, maximum boiling azeotrope because of AB interaction is stronger than AA and BB. Where it is AB interaction stronger than AA and BB. That's it. So when you nitric acid and water form maximum boiling azeotrope, when mixed in this ratio, it means what? Maximum boiling azeotrope means AB interaction should be stronger than AA and BB. In the graph, hope you remember this graph, temperature versus vapor pressure we draw. In this graph, what is this data represent? We studied this XY. The right side one is solution and the left one is which one? Solvent, right? So XY is solution, where it is PQ is solvent. PQ is the curve for solvent, XY is the curve for solution, and delta T is the, this is our delta TB, the depression in freezing point. No, that is a depression in boiling point all. So PQ is the curve for solution, no. PQ is the curve for solvent, okay. XY is the curve for solution, okay. Delta T is the molar elevation in boiling point. Yes, so that is the C answer can be corrected. And XY, what is the XY given? PQ is the curve for solvent, okay. And XY is the curve for solution, and delta T is the elevation in boiling point. That is the best answer, right, my dear? So D can be the correct answer, right? Delta T is the elevation in boiling point, delta TB. So once finally, PQ represents solvent, okay? PQ represents solvent, and XY represent curve for solution, ready? And delta T represent what? It is the elevation in boiling point, right? Next, a numerical is there. Okay, let us calculate fast. A solution containing 12.5 gram of non-electrolyte substance. That is a solute, right? So weight of solute is given 12.5 gram. It is dissolved in 185 gram water. So weight of solvent is 185 gram. Shows boiling point elevation. That means what? Delta TB, boiling point elevation is given 0.80 Kelvin. Calculate the molar mass of the substance. So MB we need to calculate. KB already given 0.52 Kelvin kilogram mole inverse. Directly upper equation. Delta TB is equal to I into KB into molality. We know delta TB already given 0.80. Or what is our main equation? Delta TB equal to what is I value? They did non-electrolyte, right? So I value is 1. So KB into what is molality expression all? WB by MB into 1000 divided by WA. So delta TB already given 0.80. KB already given 0.52. WB is 12.5. MB we need to calculate 1000 divided by WA is 185. So we need to calculate MB. So while you simplifying, just calculate, try it all of you. Around you will get 43.92 gram per pound. Please cross check it, okay? The method I'm just giving now. Next question 43. 5% solution of cane sugar. 5% solution of cane sugar. Its mass is given 342 molecular mass. Is isotonic. What is meant by isotonic? So its osmotic pressure is equal to the osmotic pressure of one another. 1% solution of which one? X. Calculate its mass. And give me a shortcut, simple idea. For an isotonic solution, we can equate their number of moles, all of you. N1 is equal to N2. For an isotonic solution at the same condition, their number of moles we can equate, okay? What is number of moles? Given mass by molar mass. Here also given mass by molar mass. Use this direct equation if it is isotonic. What is the weight of first solution? What do you mean by 5%? 5% means 5 gram. So weight of first is 5, its mass is 342 equal to. What is the meaning of 1%? 1 gram. So weight of second is 1, its mass supposed to calculate. So mass is equal to 342 divided by 5. 342 divided by 5, how much? 6 something, right? Yes, 68.4 will come. So if it is isotonic solution, please use W1 by M1 equal to W2 by M2. Why is the molecular mass determined by measuring colligative property in case of some solutes is abnormal. We studied why there is a abnormality in the molecular mass of the solute when we calculated through colligative property, because particles may undergo either dissociation or association in its solution. So when it undergo dissociation or association, number of particle changes, so colligative property changes. So due to association or dissociation of solute molecule, particle number changes, so colligative property changes. Therefore, to rectify this problem, we are using Van Hoff factor. Which of the following relation is not correctly matched with the formula, which is not correct? In case of association, we studied actually 1 minus I divided by 1 minus 1 by n. Or we can write like this, okay, I minus 1 by 1 minus 1 by n minus 1, correct. In case of dissociation, I minus 1 by n minus 1 we studied. This is wrong. What is the correct equation? I minus 1 by n minus 1, right? This is wrong. And the relative lowering of vapor pressure, correct, right? Yes. Elevation of boiling delta T equal to K into WB by MB into 1000 divided by WA, correct. 46. Which of the following has highest freezing point? Remember, higher the number of particle, dear all, higher the number of particle if it giving high boiling point, less freezing point. So high freezing point mean which is giving less number of particle. Which one? NaCl break, give 2. KCl break, AlCl3 break as what? Al3 plus and 3Cl minus. What is C6H12O6? Glucose. Glucose do not undergo dissociation, it exists as 1. So this is the one giving less number of particle. The one which is giving less number of particle having high freezing point. For which of the following solute Van Hoff factor is not greater than 1? NaNO3 breakdown as what? Na plus n NO3, it will give you 2. I have a Van Hoff factor 2. Barium chloride breakdown as Ba2 plus and 2Cl minus, total 3 ion, Van Hoff factor 3. What is NH2CONH2, my dear? This is urea formula, okay? Urea is a non-electrolyte, it do not split 1. And K4, how you break it? This will give you 4K plus outside, and which one? FeCN6, 4 minus, total 4 plus 1, 5 ions. So 4 plus 1, total 5 ions. So were the Van Hoff factor not greater than 1, urea, glucose, benzene, these all are what? Non-electrolyte. Which of the following will have the highest freezing point? Again I am reminding you, higher freezing point means the one which is giving less number of particle. Where is less number of particle? Sugar, right? Sugar, glucose, unit and all do not split. And 49, Van Hoff factor of 0.05 molar aqueous solution of KCl is, see, Van Hoff factor is already given 1.95. The degree of ionization, which means degree of dissociation. See, alpha, how to calculate degree of dissociation? I minus 1 by n minus 1. What is I value? 1.95 minus 1. What is n value for KCl? How many ions given by KCl? It will give you K plus and Cl minus, total 2 ions. So 2 minus 1. So 1.95, that is 0.95. 0.95 divided by 1, 0.95. Final answer, you should multiply by 100 because alpha is expressed in percentage. So how much it is? 95%. Okay, that's enough here. 0.95 is given. Now, what will be the freezing point of 0.5 molar KCl solution? What will be the freezing point of 0.5 molar KCl? So, molality is given to you 0.5 molar KCl solution. So, what is the I value of KCl, all of you? 2, right? K plus and Cl minus 2 ion. The molar freezing point constant, that means Kf is given 1.86 degree Celsius mole inverse. Okay, degree Celsius, the molality inverse. So, here, what is to calculate? What will be the freezing point of the solution? We need to suppose to calculate Tf. What is our equation? Delta Tf is equal to I into Kf into which one? Molality. Delta Tf, how to calculate? Tf naught minus Tf equal to I into Kf into molality. What is Tf naught? Freezing point of the pure solvent. Here solvent is which one? They did just mention solution, right? So solvent is water. Solvent freezing point 0 degree. 0 minus Tf is equal to, what is I? 2 into, what is Kf? 1.86 into, What is molality? 0.5, right? 0.5, can we write it as 1 by 2? So 2 cancel, 1.86. So what will be TF, my dear? What will be TF? TF will be minus 1.86 degrees Celsius, right? Minus 1.86 degrees Celsius. Question number 51. In a chemistry laboratory, Richard took 5 gram of solute, 5 gram of solute from an unknown box and prepared a 0.25 molar basic solution. So they given the weight of solute, right? So weight of solute is what? WB. It is given as 5 gram. And the molarity already given that 0.25 molar basic solution. The volume of the solution was, so volume also given, it's around 500 ml, ready? Based on the above data, which of the following is likely to be the unknown substance used by Richard? Means they're asking what is a solute they were used, whether it is calcium hydroxide, sodium hydroxide, lithium hydroxide or cesium hydroxide. Very simple. We have the equation for molarity, right? What is that molarity? If it is given, molarity is equal to what? WB divided by MB into 1000 divided by volume. That is the expression for molarity. So molarity is already given 0.25 equal to WB. WB is given weight of solute 5. MB we need to calculate. The molar mass we need to calculate. Into 1000 divided by what is the volume of the solution, that is equal to 500 ml. That is equal to 2. So it will be MB is equal to what? MB is equal to 5 into 2, 10 divided by 0.25. What it will be? So we can write 10 divided by this one, we can write 25 into 10 raised to minus 2. So 10 raised to minus 2 when go to the numerator. 10 square into 10, 10 cube. That means 1000 divided by 25. 1000 divided by 25 is equal to what? 40 gram per mole. 40. 40, what is the 40 with the molecular mass? What is the solute we have? That is what? NaOH, right? What is mass of NaOH? 40. Sodium mass is 23. Oxygen mass is 16. 1 hydrogen. See all of you? 40. So 40 if the molecular mass, the solute is what? That is sodium hydroxide. Clear all of you? Let's go for question number 52 for you. A glycerin solution at 293 Kelvin has a molality. So they given you molality. Okay. Molality already given 3.89 molar. And a molarity. Molarity also given. Molarity is equal to 5.33 molar. Ready? Which of these would be correct? Which of these would be correct for the molarity? For the molarity and the molality, all right, of the same glycerin solution at 450 Kelvin. What they changed actually? Temperature. What is the initial temperature, dear? 293 Kelvin. Now they increased to what? Now they increased to what? 450 Kelvin. So temperature increased. You know how the temperature affect molality and molarity. Here, molality is what? Molality is WB by MB into 1000 divided by WA. So molality is not depend on temperature because there is no factor, there is no quantities which changes with the temperature, right? All are weight. Weight do not change with the temperature. We know molality is independent of temperature, whereas what about molarity? What about molarity? You know, molarity is equal to WB by MB into 1000 divided by volume. Volume is depend on temperature. How it is depend? Directly. Volume is directly proportional to temperature. As temperature increases, volume increases. When volume is directly proportional to temperature, then what? How volume related to molarity? Inversely. So when temperature increases, molarity decreases. So molality, no change. Molality remain as 3.89. So molality remain as 3.89 itself. But molarity, initial molarity is 5.33. But when they increase the temperature, molarity will be lesser. So less than 5.33. Molarity will be less than 5.33 and molality is equal to, right? Option A, molarity less than 5.33 whereas molality is equal to 3.89. So careful all. Molarity is dependent on temperature, whereas molality independent on temperature. Let's go for question number 53. A mixture of acetone and chloroform. You see, acetone and chloroform, where we studied, positive or negative deviation, you should have a clear idea. They already said it's for maximum boiling azeotrope. That means what? It is a negative deviation, right? Negative deviation. Acetone and chloroform are an example for which one? Negative deviation. So, they're asking which of the following is correct for the mixture. For negative deviation, for negative deviation, AB interaction is, why they form maximum boiling? Because AB interaction is stronger than AA and BB interaction. Right? Or we can say solvent-solvent interaction, solute-solute interaction themselves, the bond strength is weaker than which one? Solvent and solute. Question which is correct? Change in volume on mixing will be positive. No, negative deviation means, negative deviation means, delta H mixing less than 0, delta V mixing also less than 0, not greater. So option A and B cut. The interaction between unlike molecule which means A and B is stronger than that between molecules in the mixture. That means AA and BB. Correct or not? Yes. AB interaction is stronger for negative deviation. Let's go with option which one? C. Next one. As per Henry's law, Henry's constant KH is equal to P by H. What is our actual equation? Pressure, partial pressure is equal to Henry's constant into what? The chi, right? Yes. Where P is the partial pressure, chi is the mole fraction of the gas, and KH is the Henry's law constant, everything we know. If the concentration of N2 gas in water at a constant pressure increases quadratically, they are changing the concentration of nitrogen, how will the value of KH change? Dear all, KH is a constant. KH is a constant for a particular gas. It do not change if you change the concentration of the gas, okay? So it remain what? The same. KH, Henry's constant, remain constant, right, for a gas. Next one. 342.3 gram sucrose. So weight of solute is given. Weight of solute is given 342.3 gram. All right. Is dissolved in 1 kilogram water. So weight of solvent is given 1 kilogram, which means 1000 gram. To form a solution. All right. The boiling point of water, boiling point of solvent. What is boiling point of solvent? TB naught is given. Boiling point of water is given. Yeah, already we know 373.15 Kelvin is the boiling point of water. Which of the following is likely to be the boiling point of the solution? So we need to calculate TB. So this is related to which colligative property? Elevation of boiling point. Molar mass of sucrose, so that is MB is given 342.3 gram per mole. Pressure is given KB, right? Ebullioscopic constant 0.52. So let us apply into our equation here. What is our equation? The equation is TB minus TB not equal to Van Hoff factor for sucrose 1, right? Sugar unit, Van Hoff factor is 1. No need to consider. KB into WB divided by MB into 1000 divided by which one? The WA, weight of solvent. TB is supposed to calculate. What is TB naught? 373.15 equal to KB is 0.52 into what is WB? 342.3 by what is molar mass? Molar mass is given, right? Yes, molar mass is given. That's also 342.3 into 1000 divided by what is the weight of solvent? That's also 1000. Here, cut it. Very simple, right? So what will be TB? 0.52 plus 373.15. That's equal to what? 373.67. Yes, option A. Right, clear? Next question. Which of the following statement is or are correct? First one. Sea water boils at a lower temperature than fresh water. Sea water means it contains NaCl and water. And fresh water means only H2O, right? So solute if there are more solute in the solution, vapor pressure is less. More solute comes, what happens? Vapor pressure decreases. Sea water boils at a lower temperature. Here they are asking boiling point. As number of solute particle increases, boiling point increases. So this one having high boiling point, right? So sea water boils at a low temperature, no, at a high temperature. So that is wrong. What is delta S? Change in the entropy, right? Randomness. Delta S is higher for the vaporization of pure solvent than the vaporization of solvent from a solution. Clearly try to understand. This is a solution, this is a solvent, right? Where more vapor start to generate. Here, where we have more solvent, where more vapors start to generate, because solute particles do not undergo vaporization faster, right? So solvent particle only there means they undergo vaporization faster. There will be more vapor, so more randomness. So that is a correct statement. The boiling point of water is lower than that of glucose water. Water mean only solvent. Glucose water mean glucose is there. Glucose is solute. Solute when comes their boiling point increases. So the boiling point of water is lower than glucose. Yes, 2 and 3 both are correct, right? 2 and 3 both are correct one. Next one, 10 gram glucose. Simple question. 10 gram glucose you have. Okay, 10 gram glucose is dissolved in 40 gram solution. Okay, so this is the weight of solute, this is the weight of solution. Calculate the percentage. You know how to calculate the mass percentage, right? Mass percentage of solute, how to calculate? The given mass of solute. What is the given mass? 10 divided by total mass of the solution, 400 gram into what? 100, right? Is equal to 10 by 4 is equal to what? 5 by 2 is equal to 2.5 percentage. Ready. Next one. 2 aqueous solution, okay, 2 aqueous solution, they given S1 and S2. S1 and S2 are separated by a, okay, suppose they are separated by a semi-permeable membrane. The vapor pressure of S1 is lower than that of S2. Vapor pressure of S1 is lower, right? Lower. What is that meaning? Vapor pressure lower mean which contains solute. So, okay, so this is a solution, this is a solvent. How we considered here? Yes, they said S1 having lower vapor pressure. Lower vapor pressure means there are more solute. So that means a solution. Okay, it can be taken as a solvent. Anyway, this one contain more solute. That's a meaning. Now the question, where solvent flow? Solvent always flow from what? High concentration of solvent to low concentration of solvent through the semi-permeable membrane, that is called our osmosis. So can you say here is solvent and this is what? Solution. So where is high? What is mean by osmosis? Osmosis mean solvent move from solvent to solution, or higher concentration of solvent to low concentration of solvent. That is what S2 to S1 is the movement. So they are connecting with which one? Osmosis. Remember all, number of solute particle when increases, what happen? Vapor pressure decreases. Next one, which of the following 0.1 molar aqueous solution will have lowest freezing point? Many times we discussed lowest freezing point mean they contain more number of particles. That's the meaning. Lowest freezing point mean more number of particles. See, this is glucose. Glucose do not dissociate. It exists as glucose itself. Al2SO4 thrice. How it break, all of you? 2 aluminium, right? 2 aluminium with a charge 3 plus and 3 sulfate with a charge 2 minus. Total 2 plus 3. It's giving you 5 ions. What about calcium chloride? It will give you calcium 2 plus and 2Cl minus, total 3 ions, and Na3PO4 will give you 3 Na plus and phosphate PO4 3 minus, 3 plus 1, total is giving you 4 ions, right? 4 ions. So can you say which is giving more ions that produces least or lesser freezing point? So more ions for aluminium sulfate. So this point please don't forget, okay dear, this is the point I'm telling you. Number of particles, finally, as number of particle increases, remember only the boiling point increases, freezing point and vapor pressure decreases. Please remember this point. As number of particle increases, only boiling point increases, but freezing and vapor pressure decreases. Next one, which of the following is true? Ready? The ideal behavior of a liquid solution is due to the fact that different molecules present in it do not interact with which one another. No, there is interaction, right? You know, there is in ideal solution, what we studied, AA and BB interaction are equal to AB interaction, right? There is an interaction, so it is wrong. Henry's law deals with the variation of solubility of gas with temperature. Yes. Henry's law deals with what? Solubility of a gas, that is depend on what temperature. We studied how solubility related to Henry's constant, how temperature related to Henry's constant and all. So B is the correct statement. Next one, when a solute is added to pure solvent. When a solute is added to a pure solvent, that means you are making a solution. Then vapor pressure of the solution become lower than that of the pure solvent. Correct or not? When solute added, more number of solute particles come, vapor pressure decreases. So vapor pressure of the solution become lower than that of pure solvent. Yes. Rate of evaporation of solute does not affect. No. So option, solute does not affect the rate of condensation. No, rate of evaporation of the pure solvent is reduced. Rate of evaporation, all of these are there, so we have to cross check. Okay, rate of evaporation of the pure solvent is reduced. Yeah, it is possible, right? So when a solute is added to pure solvent, first one is okay, correct, right? Vapor pressure of the solution become lower than that of the pure solvent. Rate of evaporation of the pure solvent is reduced. Yes, that's also correct. Okay, so I think D, all of these will be the answer. You can cross check. Rate of evaporation. See, if it contain only solvent, suppose it contain only solvent, solvent definitely what? Evaporate, right? So rate of evaporation will be more. But when you add solute into this one, what happens? Solute particles do not undergo vaporization faster, so it will reduce the vaporization of which one? Solvent. Rate of evaporation of the pure solvent is reduced, yes, when you add solute. And solute does not affect the rate of condensation. Yeah, rate of condensation is rate of condensation and evaporation both are depend on what? Solvent, because solvent only makes what? Vapors, right? So both, yes, all of these are correct. Yes, option D is the correct one. From the colligative property of solution, which one is the best method for the determination of molecular weight of polymer? We studied the macromolecules like polymer, plastics and rubber, or this kind of what we can say generally polymers. Okay, polymers and the biomolecules, right? Proteins and all. Their weight is calculated by what? Osmotic pressure is the best method because we can calculate at room temperature itself, and molarity is used instead of molality. So many advantages are there. 63. If liquid A and B form ideal solution, we know the properties of ideal solution. Delta, ideal solution, delta H mixing 0, the volume of mixing 0, but yes, entropy of mixing is not 0. So liquid A and B form ideal solution. What we can say, both A and B are correct. 64. Which of the following solution will have highest freezing point? Highest freezing point mean which contain low number of particles, low dissociation. See, 2 molar NaCl, 1.5 molar AlCl3, 1 molar Al2. See, very simple option D, right? Urea, glucose, sugar, these all are non-electrolyte. They do not undergo further splitting. So what we can say, the one which having low Van Hoff factor, the one which do not undergo dissociation, their freezing point will be highest. Lower the number of particle gives me higher the freezing point. Question number 65. Hope you remember this graph we studied in the depression in freezing point and all, right? Depression in freezing point graph. Question, whether they given you PQ, they're asking about PQ and QR and ST. This is PQ, this is QR and ST. This is very clear from the textbook graph. PQ represent what? Liquid solvent. PQ represent liquid solvent. On freezing, it becomes solid solvent, right? Solid solvent. And the right one is which one? Liquid, the solution. Solution. Compulsory to know the graph. The same one graph we discussed in which one? Elevation of boiling point also. This is freezing. So where it is all of you? PQ represent liquid state of, not the solution, solvent, okay. PQ represent liquid state of solvent, yes. QR represents solid state of solvent, yes. And ST liquid state of solution, yes. Let's go with option B is the answer. Question number 66. 2 gram of sugar, 2 gram sugar is get added to 1 liter of water to give sugar solution. What is the effect of addition of sugar on the boiling point, freezing point of water? Here, as number of particle increases, solute particle when increases, boiling point increase, freezing point decrease. So boiling point increases and freezing point decreases. Yes, the connection they are asking. 67, this is our osmosis process. If a semi-permeable membrane is placed between solvent and solution as shown in the given figure. Okay, let's see what happened in this one. The solvent molecule will flow through the membrane from solution to pure solvent. No, solvent to solution. That is called osmosis, right? Solvent molecule will flow continuously till the equilibrium is attained. Yes, solvent molecule will go through the semi-permeable membrane till the equilibrium attained. Correct. But there is an option both B and C. So check C also. The flow of solvent from its side to solution. Okay, flow of solvent from side to solution side across a semi-permeable membrane can be stopped if some extra pressure can osmotic pressure applied. Yes, so the correct answer is which one, dear? Option D. If you apply, if it is solvent and if it is solution, if you apply more pressure on the solution side, you can prevent the process osmosis. That is called osmotic pressure. Yes, both B and C are correct. 68. See, grapes placed. Hope you can able to see grapes here, right? Okay, so this is grapes are placed here in the solution X, Y, Z. Ready? If a beaker X contain water, the excess contain water. Okay, so this one is what? This is normal water in which this is the size of grape. All right. What then Y and Z contain? Simple, dear. Here, what happened to the in Y solution? What happened to the size of the grape? It increases, right? It swell. If the grapes particle gets swell, means what it should be? It should be an hypotonic solution, because in hypotonic solution particles swell, whereas it is shrinking. Shrinking is happen in which one? Hypertonic solution, dear. Hyper. Remember, if a particle swell mean it is hypotonic, shrink means hypertonic. So Y is hypotonic and Z is hypertonic. Let's go with option A. Question number 69. They given water here, and what is given? Hope you can able to read it. This is 1 molar glucose solution. This is 0.5 molar glucose solution. Ready? This is normal water. Here more concentration glucose is there. Here 0.5 concentration. Question. Which of the following statement is correct? Ready? Vapor pressure in all the 3 beaker is same. No. Because as the number of particle increases here, glucose is increasing. Some of them contain 1 molar, some of them contain 0.5 molar, some of them do not. So as solute particle increases, vapor pressure changes. Vapor pressure of beaker B is highest. Vapor pressure of B is highest. No, as the number of particle 1 molar more, right? So more solute mean less vapor pressure. Vapor pressure of beaker C is the highest. No, actually vapor pressure of which one is highest? A, because there is no solute. Because solute increases, vapor pressure decreases. So answer is D. Vapor pressure of beaker B is lowest. Yes, because it contains more solute than that of C, and vapor pressure of beaker C is lower than A. Yes, A is the highest one because there is no solute. Point is this one, as number of solute particle increases, vapor pressure decreases. Question number 70, study the graph. Hope you've seen this graph before. What is this first graph represent here? You know, this one represent, it is what? Deviation, positive deviation, and this one represent, it is what? Negative deviation. They are asking which is a positive deviation and negative deviation. Example, see, acetone and alcohol. Acetone with ethanol, acetone with methanol, acetone with alcohol are positive deviation, and acetone and chloroform is negative deviation. Option A is the answer. 71. When these two are mixed, which of the following is not true about the solution formed? When these two are mixed, so that species, let me just tell you that, okay. So the species are missing there. Let me just complete the question. All they will give you like this. Okay, so these are the species. Okay, these are the species. Let me just give you. And okay, so what is this compound here? What is this compound? This is the acetone, and this is what? Chloroform, right? What is acetone? CH3COCH3. This is CHCl3, chloroform. Now the thing is, so here is the hydrogen bonding and all we know. Is an AB interaction. So question, this is acetone and chloroform. Acetone and chloroform is an example for which deviation? Negative deviation. So it obey Raoult's law. No negative deviation, do not obey Raoult's law. Delta H mixing 0, delta V mixing 0. These all are for what? Ideal solution, right? Cut it. It's only on option. See, negative deviation form which azeotrope? Maximum boiling azeotrope. Okay, question is, these are the compounds. Ready? 72. Given below are few mixture formed by mixing two components. Which of the following binary mixture will have same composition in the liquid and vapor phase? What is that? Means azeotrope. What is mean by azeotrope? They are binary mixture having same composition and boils at a constant temperature without changing its, right? So that's a so same composition in liquid and vapor phase mean they are azeotrope. So which of them can form azeotrope? You know, azeotropes are formed by only non-ideal solution. Ethanol and chloroform, yes, it's a non-ideal solution. Nitric acid and water, yes, it's a negative deviation. As the means it's not obey Raoult's law, non-ideal solution. Benzene and toluene, it's an ideal solution. And ethyl chloride, ethyl bromide also ideal solution. We know ideal solution do not form azeotrope. So 1 and 2 are only possible. Clear everyone? 73. When acetone, just we discuss now, when acetone and chloroform are mixed together, we know acetone and chloroform form negative deviation. In negative deviation, you know, AB interaction is stronger than AA and BB interaction. So what is the answer? AA and BB interactions are stronger. No, AA and BB interactions are weaker than AB interaction. Yes, option C. And the two liquids form separate layer and not. Match the following. Dear, tell me all. Delta H mixing 0, delta V mixing 0. Which solution? Ideal solution, right? So A we can match with the third one. Delta H mixing not equal to 0, delta V mixing not equal to 0. That means non-ideal solution. So this is B. Next, so A3B1. What is the answer? A3B1, right? B. This is B2, right? And what about delta H mixing less than 0, negative deviation, and delta H mixing greater means positive deviation. So C with the fourth one, right? Yes, C4, right? Correct. Question 75, fill in the blanks with appropriate words. Azeotropic mixtures boils. Azeotropics mixture boil without change in their composition. Azeotropic, they boils without changing in their composition. So that is only one answer, option D dear. Check it out, composition. And they are showing what? Positive or negative deviation. And dash solution do not form azeotrope. Which one? Ideal solution do not form azeotrope. And Van Hoff factor for an electrolyte is, electrolyte means what? It undergo dissociation. During dissociation, always the Van Hoff factor is what? Greater than 1. Yes, all answer is D. 76. Match the following. Again, ethanol and water, alcohol and water, all are what? Positive deviation. Positive deviation means they form azeotropes. So this is A. A4. A4, that is only answer C. Next, benzene and toluene is ideal solution. Ideal solution, yes, it is B. B with the third one or not? Yes. Henry's law. Yes, this is the effect of pressure on gas, right? This is Henry's law and this is our Raoult's law. D with the first one. Clear all of you? Question number 77. What is the unit of cryoscopic constant? We already studied unit of ebullioscopic constant Kb and cryoscopic constant Kf. Both are same. Which one? Kelvin, kilogram, mole inverse, right? Kelvin, kilogram, mole inverse, or Kelvin molality inverse, right? Kelvin, kilogram, mole inverse. Dash is a mixture of compound with the same composition in the vapor as in the liquid and boils at a constant temperature. They are asking you the definition of which one? Azeotrope. Azeotropes are binary mixture and they have same composition in their liquid and vapor phase and they boils at a constant temperature. Now, the Van Hoff factor for a dilute solution of strong electrolyte barium hydroxide. What is barium hydroxide formula? BaOH twice. Barium hydroxide. How barium hydroxide break down? Ba2 plus and 2OH minus. So total 1 barium, 2 OH. So what is the Van Hoff factor? 3. 3 ions it can produce. And 80th question, which one of the following is incorrect? Incorrect for an ideal solution. See all, delta H mixing is 0, delta U mixing is 0, and the delta P, that is observed minus calculated, that's equal to 0. Delta G mixing is 0. Here, fourth one is something special. We studied actually, what is delta G called? Gibbs energy. We know when if a Gibbs energy 0 mean reaction is at equilibrium. But delta G mixing is negative. Then only the reaction will be spontaneous, or it is the mixing can happen. If you want to mix a solution or if you want to take part a reaction, if the reaction want to be happen, delta G mixing should be what? Negative. So for an ideal solution, Gibbs energy is not 0, it is less than 0, that means negative. Now, which one of the following electrolyte has the same value of Van Hoff factor as that of aluminium sulfate? What is aluminium sulfate? How it break down? It will break down as 2Al3 plus and 3SO4 2 minus. So 2 plus 3, total it's giving you 5 ions. 5 is the Van Hoff factor. So where you can observe 5 is the Van Hoff factor. You already studied coordination compound chapter and all. So it's very easy. The fourth is the answer. How this compound break, all of you? This is the 4 potassium outside and complex is 1 time. 4 plus 1, 5. How you write this one? 4 potassium is there plus and FeCN6 4 minus is there. 4 plus 1 total is giving you what? 5 ions, right? You know, or very simple. K4, right? So 4 is there, 1 is there. 4 plus 1, 5 ion. What about this one? Here 3 plus 1, only 4 ions. 82. PA, all right? PA and PB are the vapor pressure of pure liquid. Pure liquid, okay? Pure. Actually, we are using P0A and P0B, right? And respectively, ideal binary solution represent the mole fraction, the total pressure, we studied already, derived an equation for total pressure. What is the equation? P total is equal to P0A plus chi B into P0B minus P0A. Here instead of P0A and P0B, they used PA and PB. So which is correct, all of you, just to check it. Very simple this one. You see here A means here B. Just check it. It's like that or not. Here A. No. Here BA. Okay, it can be because there is one more equation. P0B plus chi A into P0A minus P0B. So here actually BA, yeah, it can be correct. But you see BB. Just to see this format. ABB is there or not? ABB or BAA. So is it there? AAA? No. Here you see BAA. Yes. BAA. Then B. Or anyway, nothing but you have to know the equation for total pressure. Right. For an ideal. The Van Hoff factor I for a compound which undergo dissociation in one solvent and association in other solvent is respectively. During dissociation, I value will be greater than 1. During association, always I value less than 1. So first one is dissociation, so greater than 1 and less than 1, right? So during dissociation, I value greater than 1. During association, less than 1. Question 84, which of the following is not an ideal solution? Not an ideal solution. Hexane and heptane ideal, bromoethane, chloroethane ideal, benzene and toluene ideal, ethanol and acetone, no, right? Ethanol and acetone positive deviation cases. The vapor pressure of pure benzene at a certain temperature is, so vapor pressure of pure benzene, which means P0A is given 0.85 bar. A non-volatile, non-electrolyte solid weighing, so weight of solute is given 0.5 gram, is added to 39 gram benzene. So that is the weight of solvent 39 gram. Its molar mass already given, so MB is already given 78 gram per mole. Vapor pressure of the solution then is, so vapor pressure of the solution means PA is given 0.845. What is the molar mass of the solid substance? No, so this is the molar mass of the solvent, right? So this is molar mass of solvent, okay, that is MA. So they are asking you to calculate MB. So which theory is this one? Relative lowering of vapor pressure. Let us apply our equation. P0A minus PA divided by P0A is equal to WB by MB into MA divided by WA. Ready? P0A is given 0.85. PA is given 0.845. P0A is given 0.85. Okay, equal to WB is 0.5, MB supposed to calculate, MA is 78 and WA is what? 39. So we need to calculate the value of MB. Hopefully you can able to do it, all of you. Please cross check the value. You will get around 170 gram per mole. Topic is relative lowering of vapor pressure. Next one, the boiling point of benzene is a pure solvent, right? So TB naught is given 353.23 Kelvin. When 1.8 grams solute, so weight of solute is given 1.8 gram. Solute was dissolved in 90 grams. So weight of solvent is given 90 gram of benzene. The boiling point is raised to, so TB, boiling point of the solution, is given 354.11 Kelvin. Calculate the molar mass of the solute. Again, we need to calculate MB here. KB, molar elevation constant, is already given 2.53. So which theory is this one? Which colligative property? Elevation of boiling point. The equation TB minus TB not equal to KB into, here all they didn't mention about solute, so I value we can take it as 1, okay. KB into WB by MB into 1000 divided by what? WA. Substitute. TB is given 354.11 minus TB naught is 353.23 equal to KB is 2.53 into weight of solute is 1.8, MB we need to calculate into 1000 divided by weight of solvent is 90. So MB we need to calculate here, same way of the previous one, but this is what? Elevation of boiling point. Please cross check it all. You will get 58 gram per mole. 87, 1 gram of non-electrolyte. So weight of solute is given 1 gram. Solute was dissolved in 50 gram benzene. So weight of solvent is given 50 gram. Lowered the freezing point of benzene. Lowering of freezing point, that means delta TF is given 0.4. The freezing point depression constant KF is 5.12. Find the molar mass of the solute. Again MB. These all are NCERT question, okay. So equation is, what is delta TF already given? So delta TF equal to KF into WB by MB into 1000 divided by WA. What is delta TF given? 0.4. KF is given 5.12. WB is given 1. Molar mass we need to calculate into 1000 divided by WA is what? 50. We need to calculate the molar mass of the solute. It will get, just to calculate all of you, you will get around 256 gram per mole. You have to practice it, okay? Please. 88. 200 centimeter cube of an aqueous. So 200 centimeter cube, volume, right? 200 centimeter cube, which means how much? Liter divided by 1000, 0.2 liter. of aqueous solution of protein contain 1.26. So weight of solute is given 1.26 gram. The protein, the osmotic pressure of such a solution is given 2.57 into 10 raised to minus 3. Temperature already given 300 Kelvin. Calculate the molar mass, again MB. Which theory? Osmotic pressure equation. Pi equal to WB by MB into V into RT, right? So pi, what is pi? 2.57 into 10 raised to minus 3 equal to, what is weight of solute? 1.26. MB we need to calculate. Volume is 0.2 liter. What is R value? R value we can take it as, it is in bar, right? So 0.083. In bar, what is the value of universal gas constant? 0.083, bar, liter or decimeter cube, Kelvin inverse, mole inverse. That is a value of which one? R into, and the temperature is given what? 300, right? 300. So just to calculate the value of MB here, you will get it around 61022 gram per mole. It should be a big molecule because we studied osmotic pressure method is used to calculate the molecular mass of bigger molecules. 89 for you, which is not a colligative property. We know the full colligative property. Here option D, ebullioscopic constant, cryoscopic constant. These all are not a colligative property, right? The type of intermolecular interaction present in N-hexane and N-octane. Where actually we studied N-hexane, N-heptane and all, N-hectane or N-octane and all. This is actually an ideal solution. And also, ideal solution AB interaction is approximately equal to AA and BB. But here this is not the question. N-hexane, N-octane, they are hydrocarbon, right? Your alkanes are what? Non-polar. Alkanes are what? Non-polar. Between, there is some bonds we have to study here. Between two polar molecule, between two polar molecule, there is a interaction. That's called a dipole-dipole interaction. It is stronger bond. Between two polar molecule, dipole-dipole interaction. Between one polar and one non-polar molecule, there is an interaction called dipole-induced dipole interaction. Dipole-induced dipole interaction. And the third one is between two non-polar molecule, that is called London force or dispersion force. So here, hydrocarbons are non-polar. Two non-polar species are connected by which bond? All London force or dispersion force. 91. Which among the following is least soluble in water? Least soluble in water. We already studied organic and all. These all are alcohol, phenol, ethylene glycol, pentanol. All are alcohol. Alcohols are generally highly soluble in water. Anyway, toluene is what? A pure hydrocarbon, right? Toluene is pure hydrocarbon. So there is less chance to make which one? Hydrogen bonding with the water. So they are not soluble. So option B. 92. Due to high pressure, scuba divers experience, we studied in Henry's law application. Mountain climbers experience anoxia. Scuba divers experience, what's that called? Bends, right? Trapping of small gases of nitrogen and all in the capillary tube called what? Bends. Which relationship is not correct? Is not correct. Check it all of you. Delta TB. What is a delta TB expression we have? Delta TB is equal to KB into WB by MB into 1000 divided by WA. Is it correct? They used 1 and 2. 1 for solvent, 2 for solute. Okay. So that is correct, right? What about, very simple, we can identify. It's option B because KF and delta TB. Is it correct? Delta TB means what? Elevation of boiling point. Where what is the constant? KB, right? Not KF. That's it. The molar elevation constant. What is mean by molar elevation constant? The KB, right? KB. Molar elevation constant depend upon nature of solute, nature of solvent, vapor pressure, enthalpy. What is that? Nature of solvent. KB. KB we are saying for a particular solvent. KB for water, KB for benzene, like that they are giving in the question paper, right? KB, ebullioscopic constant, KF, cryoscopic constant. This is for what? For the solvent. Okay, this depends on the nature of solvent. What does the unit mole per kg represent? Simple question. Mole, number of moles per weight of solvent in kilogram. What is that called? Molality, right? Molality. What is molarity? Number of moles divided by volume of the solution in liter. So solution which having highest osmotic pressure is known as, if two solutions having same osmotic pressure, what they call isotonic. If they are not same, one with a higher, the higher one is called hyper, lower one is called hypo. So higher osmotic pressure is hypertonic solution. 97, RBC. RBC is isotonic. Textbook is very clearly given. Osmotic pressure of RBC is equal to 0.9% NaCl solution. Our blood osmotic pressure is equal to 0.9% NaCl solution osmotic pressure. So what is the answer? Option B. When RBC placed in 0.5% NaCl, dear, just we discuss now, our RBC is osmotic pressure with a 0.9%, but now they are placed in 0.5% NaCl. What happened? So osmotic pressure lesser, right? 0.9 is equal to RBC, but 0.5 means osmotic pressure is less. Osmotic pressure less means what? That become hypotonic. The solution having low osmotic pressure, what we call? Hypotonic. In hypotonic solution, particle swell. Particle swell. So what is the answer? We can say that will swell. So when RBC placed in less than 0.9% NaCl, it will swell. More than 0.9%, it will shrink. Now, the process of movement of solvent through a semi-permeable membrane from the solution to the solvent. Solution to solvent means what? Reverse osmosis. When we apply high pressure, yes, that's reverse osmosis. And it is our 100 last question. Desalination. What do you mean by desalination? Removal of salt from seawater, right? Is removal of salt is of seawater is the application of which one? If you consider seawater left side, seawater means what it contains? NaCl and water, and normal water I'm taking in another chamber, normal water. So what is our purpose? NaCl we want to remove, right? So if you apply more pressure on the solution side, what happened? The solvent go from solution to solvent. So H2O, you will get it here. NaCl, we can remove it. That is what? Reverse osmosis. Desalination or purification of seawater is done by which process, dear? Not osmosis, reverse osmosis. So these are our 100 questions from the chapter solution. Keep practice, keep practice. We have to. There is no compromise in our marks. 70 out of 70, including your practical 100 out of 100 we have to score in our upcoming chemistry board exam. Prepare well. All the best.